Today we're going to talk about energy, work, and power. However, this lesson is quite big. That is why in your module, I only presented there work and power, right? No? So the following module will be entitled energy, which talks about the different kinds of energy that we have right now. The most, two of the things that we're going to talk about there is potential and kinetic energy. But in your module at the moment, uh, we're going to deal with work and power only. Okay. So So let's proceed then with our discussion about work and power. My definition class, energy is the ability to do work. So without energy, you cannot do such a work. In the same manner as without food, you don't have the energy. That's why you don't do your household chores. If your parents will ask you, Nak, please clean this one or sweep this one. You simply say, Ma, I cannot do it. I don't have the energy to do it. So you're not doing the said work. So for you to do work, you need to have, and you need to contain energy within you. Okay, but the discussion of the energy will be in our next module. Work, on the other hand, is moving an object by either exerting force and then allowing the object to change its displacement or change its distance from one point to another. So that's work. Wait, so those who are just admitted, kindly turn off your audio. So going to back to the discussion class, force again is a push or a pull, uh, an object or an individual. So whenever we apply force to an object and the object moves, then we created a work. But if we apply force to an object and the object does not move at all, so there's no work done. Let's look at simple example class. If you're going to push a wall in your house, you push that wall. Are you doing work there? Was there work present? Assuming that you are going to push your wall, the walls of your um, bedroom, the walls of your kitchen. Uh, will the wall itself move by the time you push it? The wall does not move at all, right? So therefore, if there is no distance made by the object, so no work is being done. Okay? So that's an example of work. There should be a change in distance for work to be done. Okay, maybe an example. When you walk, your muscles pull your bones to move. This requires energy for the muscle to work. Thus, work is being done because by the time you change your displacement from a single point to another, you gain a certain distance, so work is done there. But if standing alone class, if you just simply stand there, or even by the time you're doing the said Zoom session, by the time you're just sitting there in your chair or in your table or whatever uh, that you have it there, you're not doing work at all because there's no motion, there's no distance generated by the act of force. The force is there, but this distance is not present as of the moment. So work is not done. So these are what we're going to consider class. Without energy, we cannot do any motion. In the same way that without food, we cannot have the energy, so we cannot move at all. Atoms and molecules could not move without the energy. Stars could not shine without the energy. The energy coming from the stars for them to shine is radiant energy. Okay? The atoms and the molecules energy is what we call nuclear energy, no? Because we can generate the energy by nuclear fission of these said atoms. No? Planets cannot orbit the stars without the said energy as well. And that energy is what we call as gravitational energy. Animals could not run, could not walk, could not swim without the said energy. Thus, we really need such an energy. Even the wind has the energy. That is why we have the wind power. What's that in Isabela? Was it in Isabela? The big turbine that generates the energy from the wind. Okay, so messages as well could not be sent without the energy from your brain. So there's an example class. You're holding the book from your head. Did you do work here? First question, did you exert energy upon holding the book from your head? The answer is yes. Without the energy, you cannot lift the books from your head. Did you exert force? The answer is yes. Because maintaining the position of the book in your head, you are providing the equal force that the head should produce to equate the force, downward force of the book from your head. But the question is, if you just simply lift the book from your head, is there a work being done? The answer is no. If you just simply put the book there, there's no work being done. But if you lift the book from the bottom going up, there's work being done because there's a change in distance from the point, from the initial point where the book is located to the final point where the book was lifted. Okay? So in this question, is there work being done when you hold the book over your head? The answer is no. Okay? But of course, the bringing of the book from the ground to your head, there was work being done. But upon putting the book in your head, after it was placed in your head, then there's no work being done there. But by lifting the book again, there was work being done. Energy is being used, but work is not being done. Okay, the energy from the book, we'll just talk about more of this energy from in our next lesson class. But look at this way. If you generate a heat energy from a candle, where do you think that energy came from? Where do you think that energy will go to after the candle is being burned out? These potential questions, class, will be answered when we talk about energy. I'll just give you the idea there. Energy cannot be created nor destroyed. You cannot create the radiant energy by your own action as well. Sir Jet, can I disconnect for the Zoom? My wife is yeah, you can. You can. So the idea there, class, is energy cannot be created and it cannot be destroyed as well. It's just simply transformed from one form to another. Example, the waterfalls. No? The waterfalls simply is governed by gravitational energy. No? And the gravitational potential energy generated by the waterfall was used by the turbine to create mechanical energy. No? And the turbine from mechanical energy turned to electrons, and then it is stored in a battery in the form of electrical energy. And that is our source of energy from our light bulbs, from our appliances, if we are connected to a hydroelectric power plant. No? So it's from gravitational potential energy turned into mechanical energy, turned into electrical energy, and that electrical energy was then used by our appliances, and our appliances transform the electrical energy to heat energy. Di ba? Manginit ang ating mga appliances. Even our cell phones, our laptops, it will become hot as we use this in our Zoom session. And that heat energy will go to the atmosphere and will transform again to another form of energy. So the energy actually is a cycle as well. It will change from one form to another. But more of this will be discussed in our next session. So the concern of this module class is about work. How can we do work? How is it possible that putting a book in our head does not do work at all, but lifting a book does have a work? So we need to know two measurements in order for us to compute the value of work. One is force. So force should be present. And what was the formula for force again? Force could be equated or computed by multiplying mass and acceleration, di ba? Force equals mass times acceleration. If that is a displacement force, you'll find the net force. For example, 40 newtons to the right, and then there's an opposite force, 15 newtons to the left. So the net force there would be 10 newtons, right? So 40 to the right and 50 to the left, the net force there is 10 newtons. But if there is no such opposing forces, you just have to consider one force being used with the formula mass times acceleration. If that is in a centripetal motion, to find for the force, you'll get the square of the velocity divided by the radius, right? So force equals velocity squared divided by the radius. Please put this in your common sense, mental faculty. Remind yourselves of the formula for force every now and then. Okay? So if you need two things, class, and one already is being mentioned, and that is force, the other thing that you need to consider for work to be done is distance of, of the movement, or the change of position from one object to another. If there's that movement, if the object moved from one point to another point, then distance is generated, application of the force together with the distance, then you have the formula for work, which is force times distance. The amount of force should generate a distance for work to be done. So imagine in the formula class, if there's no distance traveled, so distance equals 0. Even if you have a 1,000 Newton of force, but if your distance is 0, so 1,000 times 0, work done is 0. That is why if an object won't move at all, even if how strong you are, then there's no work being done. Get it? What will be the unit of work, class? If you're going to get the unit of force, that is Newton, right? Diba? And what is the unit of distance? It could be meters, kilometers, centimeters, and the likes. So in this lesson, we are going to generate the unit of distance in meters. Okay? So if the distance is in meters and force is Newton, so the unit of work is Newton, meter, or joule. Okay? That is actually the person who proposed the unit joule. Forgot the name. A while ago, this is Isaac Newton. Okay? But this one is, let me search the internet. What's the name of this one? By the way, 1 joule is equal to 1 Newton per 1 meter, or 1 Newton meter class. So there's a conversion here. 1 joule equals 1 Newton multiplied by 1 meter. Joule. Okay. The name of that person is James Joule. Okay? James Prescott Joule. I will type it here, class. Is it not in my notes, class? To bring back his wife from the underworld. This is the proponent of the unit of joule. By the way, joule is the unit of energy. Again, joule is the unit of energy. The standard unit of energy is joules. So 1 joule is equal to 1 Newton multiplied by 1 meter. In other words, if you have joules, 1 joule, that is equal to 1 Newton meter, 1 nm. Do not be confused. The notation 1J and 1 nm is just the same. Again, 1 joule is equivalent to 1 Newton meter. And joule is the unit of energy. It's a unit of energy. Let's proceed with examples. Probably the next year, we'll end up with examples. Or B in front is Orpheus, behind Orpheus is Eurydice. And that Orpheus should we have here an example, class. If you lift a 3 Newton book 2 meters off the floor, how much work did you do? If you lift a 3 Newton book 2 meters off the floor, how much work did you do? Going back to the formula for work is force times displacement or force times distance, right? So what is the value of your force in the problem? Force is equal to 3 newtons. Whereas the distance that the object moved from the floor is 2 meters. To simply multiply 3 times 2, the answer is 6 Newton meter or 6 joules. Question? Clarification? So how easy is our lesson? Very easy, sir.
Again, sir.
Yeah?
Again, sir. Can you repeat it again, sir?
Okay, so again, the problem goes like this. If you lift a 3 Newton book 2 meters off the floor, how much work is being done? You look at the problems given. Analyzing the given of the problem, we have here 3 newtons and 2 meters. So 3 newton is our force and 2 meters is our displacement. From the formula, force is equal to work is equal to force times displacement. You just have to substitute the units or the values of your force, which is 3 Newton, and distance, which is 2 meters. So the answer there would be 6 Newton meter. Okay? So if you are going to multiply 3 times 2, the answer is 6, and then you copy the unit Newton times meter or Newton meter. Thus, the answer for work is 6 joules. Since 1 Newton meter is 1 joule, so 6 Newton meter is 6 joules. Just simply apply the formula. What is the formula for work? Force times displacement or force times distance. So can we have the unknown, the distance, given the value of your work, which is in joules? The answer is a yes. Please also remember the triangle of formulas. I don't know if you are adept to the triangle of formulas. If you are going to make the triangle of formulas here, what will be the unit in the top? This is work here, and then force will be here, and then distance will be here. In other words, if you are going to find the value of, if you're going to find the formula for work, you have force times displacement. If you're going to find the formula for force, given the work and the displacement or distance, you have to divide. Work equals, force equals work divided by displacement, or displacement equals work divided by force. Whatever the formula being used, for as long as you know the general formula, which is work equals force times displacement, then you can solve problems under our lesson. Probably we'll have another problem here. Another problem. Problem number 2. We have here, a man pushes a couch a distance of 0.75 meters. If 113 joules of work is done, what is the magnitude of force applied? In other words, this problem goes back to the unknown, or goes to the unknown, which is force, given 113 joules of work and 0.75 meters the distance traveled by the couch. So from the formula, work equals force times displacement. If the unknown is force, what will be the formula? Imagine the triangle of formulas class. Force on top, rather work on top, force and distance is in the bottom. So if you look at the placement of work and displacement, it is one over the other. So therefore, force equals work divided by displacement. Okay? So what is the value of your work? 113 joules. Displacement or distance is 0.75 meters. So you divide class. 113 divided by 0.75. Perhaps you can use your calculators there if you have one. So divide 113 by 0.75, you get 151 Newton. How come that the unit is Newton already? So from the unit of joules class, which is equal to Newton meter, So joules divided by meter is equal to Newton meter divided by meter. Cancel the meter, so your unit then is Newton. Of course, if the unknown is force, your unit should end up with Newton. Okay? So, what is the idea of our lesson class? It's just simply applying the formula correctly using the correct given as well. No? At this point in time, being a grade 8 student, you should know better how to apply values in a given formula. Questions? Clarifications?
Sir,
Yes?
sir.
Yes, yeah.
Like when will we round up, sir, like sa whole number?
Probably I just use the rounded value here. May get my calculator from. So the exact value here is 113 divided by 0.75. You can have the answer 150.67. Okay? You can have
Okay,
the
sir.
answer. I just,
Thank
I
you.
just, I just, I just, bololong ka daw na. I just thought to give the whole value here. But by exactness of the value, it should be 150.67 Newton. Get it? Clarification? Okay, perhaps let's move to the next problem. This problem now focuses on the other unknowns. Given 3,480 joules of work required to move an object using a force of 675 Newton. How far will the object move? So since we are going to ask for the distance traveled or how far, the unknown here is distance. And if the unknown is the distance, you look at the triangular formula, we have work is on top of force. So the formula there goes with work divided by force. So you divide 3,480 joules by 675, you'll get the answer 5.16 meters. So that would be 5.155555556 or 5.16 meters. In relation to the question of a while ago, probably I'll just put an end to the 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 query of everyone. We'll have our answers to the second decimal place. Express our answers. If it is a decimal, express it to the second decimal place. Questions in this problem? Let's have another problem class. The third floor of a house is 8 meters above the street. How much work is needed to move a 150-kilogram refrigerator to the third floor? You look at the given class. The given is 8 meters, which is the distance that you need to move the refrigerator. But when you look at the other given, 150 kilograms, that is the mass of the refrigerator. Tama? So when we go back to the formula for force, or for the formula for work, that is force times distance. Right? But if you look at it, wala tayong force na binigay. So how can we determine the force given the mass of an object? Babalik at babalik tayo sa formula ng force. What was the formula for force again? Mass times acceleration. Right? Meron ba tayong mass? Meron ba tayong mass? Meron. The mass of the refrigerator is 150 kg. Meron ba tayong acceleration? Wala. Pero look at the problem class. The refrigerator is going to move above the second floor or third floor of the house, which is 8 meters from the floor. So that acceleration, we can use the acceleration due to gravity, right? So therefore, work can be computed by finding first force using the formula mass times gravity or mass times acceleration. So this is the force class. Force equals mass times gravity. The gravity there is the acceleration there class is noted by the gravitational acceleration. So we have 150 kilograms times 9.8 meters per second squared. You'll get the answer 1,400 kilogram meter per second squared or 1,400 Newton. So nanatay force, which is 1,470 Newton. And then we have the distance that we need to move the refrigerator at 8 meters. So work therefore is 1,470 Newton times 8 meters. We'll get 11,000 joules of work or 11,760 joules of work. That's our final answer. Question regarding this problem. This
Sir,
kind
what's
of a
MG?
Sir,
problem, huh?
sir,
What is MG? MG, wait ha, I will use annotation. Diba, when we talk about force, ay, di ba klaro to yun? Diba, when we talk about force class, it is mass times acceleration, tama? But this kind of a force right now is an upward force. An upward force can be equated to weight. And what is the formula for weight? Mass times gravity. Still, the acceleration is now noted by g, and that g is the gravitational acceleration of a free-falling body. That is why we use 9.8 meters per second squared to signify the unit value of gravity. And then 150 kilograms for the mass of the refrigerator. Multiplying the two, you will get the force, which is 1,417 Newton. Naintindihan ba? Shania, you understand? Sige,
Yes, sir.
ask a question. Ask a question para if naglisod pa,
sir.
we can... yes, Aya, Aya. Aya, Aya.
If there's no acceleration presented, sir, we'll use the gravitational, ano?
Put it this way, Aya. If you move an object in an upward motion, the acceleration there is the gravity. But if you move the object horizontally, then you cannot use the gravitational acceleration. Okay? But you
Okay,
can
sir.
cater to that notion, Aya rather. You can put that as well as a simple shortcut. If walang acceleration na binigay, gravity yung gagamitin natin. Yes, you can use that one. But in not all cases, for example, the motion is horizontal motion, then gravitational acceleration is not required.
What was that, sir? You froze, sir.
I froze, sorry. If it is a horizontal motion, then you need not to use the gravitational acceleration. There should be an acceleration present if it is horizontal. But if it is vertical motion, then the acceleration there should be then the acceleration there should be using gravity. We'll use the gravitational acceleration there.
Okay, sir.
Okay.
Thank you.
Okay. Any other concern? Clarification? None? Okay. Do you think you're happy so you understand the lesson? Okay. Or the other way around, you're happy that the lesson is hard. Let's have another problem, class. This one. A toy truck is pushed across a table 8 meters north and pulled back 8 meters south. If a constant horizontal force, this is the time that you're not going to use the gravitational acceleration, yeah. So if a constant horizontal force of 50 Newton is applied to in both directions, what is the net work of the net work? Net work means the final work for the said object. subtracting already the unnecessary values. How about you try to solve this one? Kaya, dili? Probably not. Okay, when you talk about the pushing of the table going north and the pulling of the table going south, what do you think of the two directions, class? The directions are actually opposing directions, right? Diba? If you push the table north and then pull it back south, then what is the distance traveled by the object? May chat tayo. Zero, very good. Walang distance yung na-gain ng object. Therefore, if the distance traveled is a zero, what do you think will be our work? There's no distance being gained by the object, so work is not present. Walang work na nagawa yung object. Again, if you push the object north 0.8 meters and then you pulled it back again south 0.8 meters, then distance traveled is a zero, so work done is also a zero or no work being done. Put it this way again, put it in your mind, pag walang distance na nag-gain yung object, walang work na nangyayari. Kahit na gano'ng kalakas yung pag-push mo sa object. This one, class. When you carry a heavy bag of groceries from your car to your kitchen, what does work? Who does the work? Something like that. Or what part of your body does the work? Is it your arms or your legs? Okay. Gabriel said legs. Shania said legs. Do you agree to Sanaya and Gabriel? Let's put it this way, class. This is the explanation there. Your legs is the one that does the work. Sanaya and Gabriel does it, right? Your legs does the work because your legs probably is the one that gains the distance being traveled. Whereas your hand is only applying the force that holds the bag in place. But your hands does not move at all. If your hands move, what will happen to the grocery? It will fall down. Get it? Clarifications for work? Fine. So we will talk about energy. We will not discuss this one. What energy? Let's proceed to power. Ay. We will talk about this one again. Why do we get tired of doing work? Because we run short of energy. Of course. This one. Okay. We will go back to that slide if we will talk again the concept of energy. So what is power, class? Power is the rate at which work is being done. Or in simple terms, power is the rate of work. When we use the word rate, we associate it with a fraction. When you do the concept of finding the rate, you're actually presenting a ratio of one unit over the other. Okay? So more power means, is it more work or what? So more power means more work done in the same amount of time. And more power means the same amount of work done in a lesser time. Okay. Let me use two of you guys as an example. Let me use Micah and Shania. Okay. Micah and Shania was actually tasked to clean the room, assuming that this is in a normal classroom setting. No? Micah was tasked to clean the room on a Tuesday, while Shania was tasked to clean the room on a Wednesday. On a Tuesday, Shania finishes the cleaning of the room for 30 minutes. No? On a Wednesday, who was Wednesday again? Shania or Micah? I forgot. Okay, let me go back. On a Tuesday, Shania finished cleaning of the room for 30 minutes. Whereas on a Wednesday, Marika finishes it in 20 minutes. Okay? Again, Shania finished it in 30 minutes, while Micah finished it in 20 minutes. So who was faster in cleaning the room? Was it Shania or Micah? It's Micah, correct? So the next question goes like this. Who is more powerful, Shania or Micah? I mean, with respect to the cleanliness, not that you have superpowers or whatnot. With respect to the cleanliness, who is more powerful? Who has more power? Shania or Micah? Let me see a comment here. The answer is Micah from Mary Claire. Maybe Mary Claire is a friend of Micah. Who will support Shania? Who is a friend of Shania here? Who will support Shania? Shania, sorry Shania, wala kang friend. Uy, Micah answered Shania. Krisha Shania. Okay, the answer is Micah. Micah is more powerful than Shania. Why is that so? If you look at the rate of work class, this is the formula, huh? A person that is more powerful is faster than that of the less powerful. Okay? As in this case, this is, I believe, Usain Bolt is more powerful over the other. In other words, the concept of the concept of power is inversely proportional to time. Lesser time means more power. More time means lesser power. That is what I mean by inversely proportional. Okay? So, um, it's 10:45. Okay, going back. Shania finishes cleaning the room for 30 minutes compared to Micah, which is 20 minutes, right? So, between the time of Shania and Micah, Micah finishes the job at a lesser time. Therefore, Micah exerts more power than Shania. Okay? Since time is inversely proportional to power. A car with a more powerful engine can accelerate a 60 meters per hour faster than a car with a less powerful engine, of course. Okay? Um, in calculating power class, we're going to use the unit of watts. This is, I think, James Watts. Again, the proponent of the unit watts. Let me see the name of James here. Okay, my internet is slow. Done. Search. So the name of what is, where are you? It's giving me a different name. Later, I will chat the name class. So the unit for power is watts. Okay, and we will use the small w because the bigger W is for work. Okay, but there are times that I need you to write the word watts or watt. For example, 1 watt, 2 watts, 5 watts. So can we agree that when we are going to find for the value of power, or if there's a problem that asks for power, you write the complete word watts to signify the unit of power, because it might be that it will you'll end up writing the W for work. Okay. Okay, good. So the unit of power is watts, given by this person. I forgot the name of this one. Um, so we have to know as well two things in determining the value of power class. Isa na dyan ang work. Since power is the rate of work, so we have the work and the time. And the formula there would be work divided by time. Okay? Or power equals work over time. So, additional formula na naman. Sir, ang dami namang formula na gagamitan namin dito. Yes, ang dami talaga. This is in connection with the subject itself, physics. These are physics lessons that you need to remember when you go to grade 9, grade 10, most especially when you reach senior high, grade 11, and grade 12, where you have the subject itself, physics 1 and physics 2. So the formula for power is work over time. So work is divided by the value of the time. Probably it could be in seconds or in minutes or in um, hours. But in this lesson class or in this value, the unit that we're going to use for time is second. Okay? So if the given unit is minutes, convert that to seconds. How many seconds are there in 1 minute? 60 seconds. So 1 watt is equal to 1 joule per second. This is the unit of watts class. 1 joule per 1 second. Joule is 1 Newton multiplied by 1 meter. 1 watt is 1 joule per 1 second. So let's try to have a problem to understand the value of power. In this problem, if an engine does 100,000 joules of work in 10 seconds, how much power did it use? So what is the power of the said engine? Power is equal to work divided by time. So therefore, work is 100,000 joules divided by 10 seconds. So your
10,000.
power is 10,000. Correct. Very good. Simple computation, no? But this solution class is noting the W. Please do not be mistaken of the W here and the W in the formula. So for us to understand and to get the final value of power, can I ask you to change that to watts? In other words, the final answer could be 10,000 watts and not 10,000 W. Good. Problem number 2. Since power is equal to work divided by time, and work is force times distance, so we can also have the formula for power, which is equal to FD over T, or force times distance divided by time, which is the same with what we have as the formula beforehand, which is work divided by time. Okay? So let's have a sample formula here, class. I did not give work, but we will calculate the work. So example number 2. If an engine exerts 3,500 newtons of force that allows the car to move 50 meters in 10 seconds, how much power did it use? So from the formula, work equals force times distance. So you can multiply first 3,550 to get the value of your work. And then after that, you divide 10 seconds to get the value of your power. Or you can have directly the formula, power is equal to quantity force times distance divided by time. Diretso na lang. So to eliminate a long solution in our problem. So we have force is 3,500 Newton divided by distance, which is 50 meters, divided by 10 seconds. So you'll get the answer 1,000.
17,500 watts.
Yes, correct. This is just a solution to the numerator first. 175,000 joules divided by 10 seconds. So the answer is correct. Was it Shania who mentioned it? 17,500 watts. So quite easy, right? It's just simply looking to the given, and then from the given, you have already the process in how to find the answer, applying the concept of multiplication or division. Hi, Garrett. Is it Garrett? Hi, Garrett. Di mo nagad si Garrett, eh. Hi, Garrett. Okay. Let's continue. Let's continue. So we have that example number 2. Therefore, if you have the answer 17,500 W, I wish you to give me the correct answer, the correct word of W, and that is watts. Questions, class? Watts can also be used to determine how powerful your machineries are in your house. In your example of ways is your light bulb, diba? When you buy a 5-watt light bulb versus a 15 watts light bulb, which is more powerful? Of course, the 15 watts. But it also consumes a lot of energy. No? But a lesser watts is lesser energy. Something like that. Okay? So here are a watt measures work done and energy used in an amount of time. Perhaps we will not deal more of this slide since it's talking about energy, no? So joules is also the measure of energy, as I mentioned a while ago. So a watt is energy used per second. Example, in your house, if your light bulb is 5 watts, so it consumes 5 joules of energy per 1 second. Get it? So if you turn on your light bulb, which consumes for 10 watts or which has the power of 10 watts, so in every second that it was turned on, it gains an energy of 10 joules. Imagine a imagine a imagine a stronger and a powerful light bulb. No, it will it will give you a problem when the electrician will read your electric bill. Probably it's not your problem, but it's your problem for your parents. So we'll deal more of that one when we discuss energy. So far questions regarding work class. Okay, what is the formula for power again? Rob Bantol, if you are still with us, power is equal to.
Work time. Also, can I say the other one, sir?
Sige.
Work times. Wait lang.
Don't look at
Work
the notes.
times. Work times time.
It's a notes. It's work divided by time, not work times time.
Joke.
Joke.
Distance. Force times distance.
Kalipog na siya. So, power is work divided by time. So, the definition goes with the formula. Since power is the rate of work, therefore, you find the rate of work, it's with respect to the time work is being done. So, therefore, the formula is work divided by time. How about the formula for work? Erwin. Oh, Erwin turned off everything.
Force times distance.
Very good. Force times distance. So work is force times distance. Power is work divided by time. Two formulas only that you need to remember. After all, the manipulation of the other unknowns is from the two formulas. Get it? If you find for time given the power and work, manipulate the formula. If you need to find the force needed to move an object at a certain work with the distance, then you need to manipulate the formula. Again, you only have two formulas to remember, class. Power is equal to work divided by time, and work is equal to force times distance. Get it? Questions so far? Clarifications? None. So I think we are already, it's already time, class. So can we call it a day? Goodbye and thank you, everyone. Bye-bye.